Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our learning on CO2 sequestration modeling using CMG software. In previous video, we have talked about the solubility trapping, and we use in that previous case, we used Lingham's method for our Henry's constant, Henry's correlation. Okay, so now we will use another method, and today we will use Harvey's method. All right, so what we are going to do is simple. I'm just going to copy this 3A and then paste and then change it to 3B like this, and I will rename it to be Harvey because we will use Harvey method. The other thing will be exactly the same. So let's enter the 3B. And you see we can delete some data here like this, and the RST and SR3, not important for now. And then we can also delete this one. We will maintain the dot dot, and dot out can be okay, so we will remove them and let's rename it. First exercise, this is for the builder, we change it to 3B, and then this one we can also change it to 3B for the WinProp. Okay, and again, we will change the Henry's law constant correlation from Lingham's method to Harvey's method. And the first thing is we will change the method that we will use inside the WinProp. So let's go first into the CMG launcher. Okay, so now we are in CMG Technologies launcher. Let's go into our folder. I think this one, expand, and then let's go to 3B. Let's use the WinProp, this one, and then drag it and put it onto the WinProp. Okay, so now we are inside the WinProp. Okay, and then we can first go to title, and let's change it to 3B. Okay, case 3B, structural hysteresis solubility, and let's change it to Harvey's method. Okay, Harvey's method, and for the test line 1, and then we will maintain the Peng Robinson 1978. Okay, and then for the equation of state, unit kPa, and then fit in mole. Okay, and let's go to CMG GEM EOS model. Again, we maintain this print component properties for GEM to WinProp case 3B structural hysteresis solubility. We will maintain the reservoir temperature for GEM fluid model to be 50 degrees centigrade, and we will use Rocho aqueous density and use Kestin print aqueous phase component solubility parameter, and for the recalculate solubility parameters at temperature and pressure below at temperature of 50 degrees centigrade and pressure 11,800. Okay, so far so good. And what else? Yeah, just to check it later, we'll use this window for mineralization. Okay, it's another kind of CO2 trapping. Okay, we will use that. And okay, the main thing is we go to component selection properties. We'll maintain our components, all right, CO2 and CH4. And now let's go to not this one, but aqueous phase. Okay, so very easy. What we are going to do is just select from Lingham's method 1986 Henry's law of constant correlation to Harvey's method. Okay, so let's just change it to Harvey's method from Lingham's method. Okay, just to make sure everything okay, I think we are good. So CMG Gem EOS model. So now we can just run. Okay, so now the simulation has been completed. Okay, if I maximize, okay, you can see here we have solubility. Okay, we can see there Harvey. We can still see temperature of the reservoir, temperature, pressure. Okay, simulation graph, but that's not the main thing. Okay. All right, so we can leave the WinProp and we will go to the file that has been created, the .gem. Okay, so we will close the WinProp. Okay, so now we are back inside our folder. Okay, and you can see we have generated several files. Originally, we only have two DAT files, but now we produce .gem and out and srf. Okay, so now we will check the gem. This gem is produced from the WinProp. Open it. Okay, you can see some keywords. Now, after opening the text, okay, we know and we notice keywords solubility. Okay, and then now we have Henry's correlation or correction for CO2. And we also have for C1, but it's not important. We will neglect this one. Okay, so now let's just compare it with what we have in 3A, just to make sure the .gem from WinProp. Okay, this one also from WinProp. Okay, okay, this one the same. Okay, let's arrange it like this. Okay, so that we can see the difference. And then aqueous density, Rocho the same, and then coefficient. Now we have here solubility. Henry's calculated at 50 degrees centigrade, and then we have this, and then we have like this, but now we only have solubility, Henry's correction, CO2, and then C1, you see? And after the solubility, okay, to the top, I think they are the same. We have Fishy, viscosity, and then omega A, omega B, they are the same. Okay. Okay, so you can see now after we change the setting inside the WinProp from Lingham's method to Harvey's method, we notice there are changes. And we will leave the Lingham's method and then go back to the Harvey's method, open this one, and then I will take two keywords here, solubility, and then Henry's correction CO2. Copy. Okay, we can neglect this one because the CH4 is not the important thing. And by the way, you know, C1 is not dissolved into the aquifer water, into the brine. Okay, so we will just neglect the dissolution of methane into the aquifer brine. But CO2, of course, will dissolve into the brine. So that's why we copy this one and then we put that inside our DAT for the builder. Okay, and then let's remove this. Okay, this one, solubility, these keywords, and then Henry's, and then ref pH, V infinity is for Lingham's method. Okay, I hope it is clear. You can check the previous video. We input these keywords because we now apply solubility trapping, but we use Lingham's method. Now, after we use Harvey's method, we can just delete them and then put the two new keywords like this and then save. Okay, and as usual, we will go back into our CMG Technologies launcher, and now we will run this DAT builder file with Harvey's method in it. We will run it using the gem, and later on we will do visualization using results. Okay, so let's go now into our CMG Technologies launcher. Okay, now we are ready to put our DAT onto the gem. Okay, let's submit the job and let gem does the job. We produce new files. Okay, normal, running, local, easy. Okay, and of course we will later on compare it with the Lingham's result. Almost there, almost ready. Okay, completed. So we can now check the dot out. Okay. Okay, we can find maybe, yeah. Okay. After how many days? Okay. Let's go. Maybe the last one. Okay. 2200. And then we have this. Let's compare it with what we have in 3A. And then let's check the dot out as well. Okay. Go to the year 2223. Almost there. Almost there. Okay. This is it. Okay, and then let's compare it with 3B. So this one is using Lingham's method, and on the right side we have the Harvey's method. Gaseous phase 0, good. Liquid phase 0, good. Supercritical. Now you see the difference between Lingham's method and Harvey's method. Trap gas saturation below critical gas saturation due to hysteresis different, and also dissolve in water also different. Okay, although the difference might be just small. Okay, just small difference between the two. Okay, but yeah, they are different, and that's the main thing that we want to see in this particular video. Okay, we have two methods, Lingham's method and Harvey's method. Okay, and Harvey's method uses a correlation to estimate Henry's constant. Okay, so we use correlation. So by the way, I need to correct my statement previously. I thought that CORR is correction. No, it's correlation. Okay, so I take my word. CORR in the keyword is not correction but correlation. All right. Harvey's method uses a correlation to estimate Henry's constant, which is more suitable to cases where there are thermal effects in our model. Since the model that we have doesn't involve thermal effect, the the difference between the Lingham's method and Harvey's method is, maybe we can say it insignificant. But if we include thermal effect in our model, the difference will be more significant between Lingham's and Harvey's method. Okay, so I think we are good. And yeah, why not if we visualize the result using results? I will drag my SR3 onto our results. Okay. And then, okay, so now let's go to IK2D view and then go to display, and then we can check the water saturation or of course gas saturation. Okay, gas saturation, beautiful. Okay, so now again the CO2 plume at the top is quite short because more CO2 is being trapped by hysteresis trapping and solubility trapping. Okay, so we reach the final time, and we can also change it to gas saturation below critical gas saturation like this. Okay, now I'm interested also in comparing the result from 3B, the Harvey's method, with the Lingham's method. So let's click on Add File, and then let's take our 3A and then this one, the SR3 for 3A. Okay, and then let's drag the result onto the dashboard and combine the results. Okay, so now we have two windows. This one is 3B. Actually, we need to change the name, yeah, but doesn't matter. On the left, we have 3B, the Harvey's method, and on the right, we have 3A. We have 3A, the Lingham's method. Okay, let's go to display, change it to IK2D view for, okay. All right, now we go to gas saturation first. Play. Okay, I see difference between the two, but maybe just a slight difference. Okay, let's track the value 0.787, 0.79. Okay. Okay, now let's check the saturation, CO2 saturation at the top, 0.791, 0.793. Yeah, but this 171,791, actually they are the same. We can say they are the same. The difference is very insignificant. Okay, and let's check go back, and then the gas, I mean this one. Okay. Okay, good. visually they are the same because numerically they are very close. Okay, very good. All right, and maybe last thing, because everything that I want to say about the result for harvest method, I think I already said that in the video of Lingham's method. So maybe we can also check the water mass density. Where is it? Wow, right. They are, yeah, let's just go back and then, sorry, just make sure the legend the same. Maybe we use that scale and then A3. Okay, and lowest value the same, so let's play. Yeah, visually they are the same. You see water, heavier water because of CO2 being dissolved into the brine. We can see they move downward because they are heavier than other brine without CO2 dissolution. Okay, so now you can see green color thicker here than the green color there, far field. Okay, so I think pretty much that's all that I want to deliver here. So the main point of this video is to present to you that we have another method for the Henry's constant, and it is Harvey's method, which is very important and very useful in the case where we have thermal effect. If you don't have thermal effect, then most of the time the Harvey's method and Lingham's method will give you very close value. Okay, so we will stop here, and in the next video we will again apply the solubility trapping, and we will use Harvey's method, but not in limited aquifer, but we will apply it in infinite acting aquifer. So it will be very interesting. And that's all. I hope you enjoyed this video. I hope this video is useful. Thank you so much for watching, and see you again in the next CO2 sequestration videos. So thank you and see you.